Okay. A couple true and false questions. Spelling's not important as long as I can tell what the word is. And there's a few true and false questions. There's a few circle the right answers. But most of them are fill in the blank. There's a total of like 50 possible. There's 50 questions and they're worth 2 points each. Okay, there's no business on the test. There's no production on the test. There's no noise reduction on the test. But all those three areas might show up on the last test we had. Okay? What?
Business production.
Business production and noise reduction won't be on this test. But they might be on the next test. In fact, you can count on them being on the next test. Okay, well, Dave and Jim are going to handle the test review for a while here, so I'll let them get started with you and have fun, okay?
See you, Jim. Okay, who's got questions? Okay, see.
Why don't you answer questions?
Well, now, okay, I will ask you questions if nobody has a question right off. I mean,
What's the answer to number one?
huh? We have some. Okay. Right along. Say what?
I do songs first.
Okay, next question.
The ideal sound source?
Yeah.
The ideal sound source is an infinitely small sphere radiating in all directions, suspended in space.
What?
You got time. Do it.
Engineer?
It's suspended in space. There's no air, so how does the sound care?
It's suspended in air. I mean, an unrestricted space, meaning no walls or boundaries.
South space. Getting to Mars. Those bird feeders. Space.
What it's saying is that it doesn't have any size to shadow sound radiating from one point. For instance, if you had a microphone that would be bulky, it would cast a shadow where the sound wouldn't reach it, or if it was a speaker, such as the speaker cabinet, high frequencies wouldn't be as good coming from the rear as they would from the front. So that's what the suspended in space means. Infinitely small, I mean. Ask another good one.
Got on the test.
What's your name?
What? Say it again.
Crossover phase dysfunction.
Crossover phase distortion. Are you referring to crossovers from speakers? Okay.
You mean a two-way speaker system, for instance, that has a high
Speaker system.
a what?
It's a multi-speaker system.
Okay, multi-speaker systems, meaning something other than one radiator, such as a woofer and a tweeter. Crossover phase distortion is when both speakers, the woofer and the tweeter, are doing the same frequency. It only happens right at the crossover point because that's the only place that both speakers will reproduce the same note. And it's the interaction or lack of between the two drivers that cause that. Such as cancellation. If both of them, if they were out of phase, for instance, at 1K, where they say it was crossed over 1,000 cycles, if the woofer and the tweeter were out of phase, the 1K would cancel right there if they're both doing it. If they're in phase and they're both reproducing the same frequency at the crossover point, then they double and you get a hump or a peak at crossover frequency.
Yeah.
That's how you make sure they're in phase.
In phase, and then usually you have a attenuator on the high frequency driver in a passive situation, so that you can adjust the level between the two and make a flatter response. Also, a lot of active crossovers have a dip at the crossover point that you can reduce the level of the crossover frequency. So if the two high and low speaker overlap and create a hump, you can bring down the frequency at the crossover point and flatten it out.
But how do you make sure that they are in phase so that they don't cancel each other?
You can hook them both up by the red terminal. Well, in the case of some manufacturers, JBL speakers are out of phase to everybody else that makes speakers in the United States. So if you're hooking up a Altec horn with a JBL bass speaker, you have to put the JBL out of phase in order to be in phase with the Altec. So what you can do is you can use a frequency analyzer, real-time analyzer, and see which way, see whether they add at the crossover frequency when you plug them both in, or whether they subtract. And it doesn't matter which way they're hooked up as long as they're both the same.
What are they doing different?
What's that?
What did JBL do different?
Why?
Could it be because James Lansing was one of the first people to perfect these weird speakers?
Well, yeah, but there was a lot of speakers being made before JBL came out with their line. So I really don't know why they're out of phase. They just are.
It didn't make any difference.
It doesn't make any difference as long as they're hooked up in phase.
Yeah, but it didn't make any audible difference.
No. In fact, you can't have in and out of phase with one speaker. It's got to be the relationship of two speakers to be in or out of phase.
Could you explain the currents are transferring to adjacent tracks?
Mr. Egan.
Okay. What are we talking about when we're transferring? Bouncing tracks, ping pong, and there's a couple names for it. Let's take the case of a 8-track recorder. And say you put some drums down. Tracks 1 and 2. Maybe a bass guitar on 8. Okay. You've got 2 rhythm guitars. That's, let's see. Okay. You're starting to get crowded on your tracks, okay? And you have maybe background vocals to do. You've got 2 tracks of background vocals to do, okay? Here's an example. What we can do is we can do a vocal here on 4 and 5, 1 vocal each, and say we want to double those. Well, I only have 2 tracks left, but I want to use 1 for a guitar lead and maybe 1 for a tambourine or something, okay? So I have a problem. I don't have enough tracks. Here's what we can do. We can bounce tracks. With drums on 1 and 2, rhythm guitar on 3, bass guitar on 8 there. We've got vocals on 4 and 5. Now, I've got 6 and 7 blank. One of those tracks I can record on, one of those tracks I can't record on. For the reason what she was asking about. You cannot record onto adjacent tracks when you're bouncing because you're trying to put information on this track that already exists on this track, and the feedback loop will start happening, okay? And in fact, the more level you try to put on this track, the more feedback you're going to get. You could get away with a real light level. Of course, we don't want to do that, okay, to avoid that feedback loop, but what we'd rather do instead is plan our tracks so that 2 tracks we might want to bounce don't end up right next door here. We want to at least jump a track over, okay? So there's a gap in between there. That's the one rule you have to follow when you're bouncing tracks.
Dude, is that because of like bridging circuitry in the recording modes?
Yeah, both tracks are in record, and they're so close together. What you're doing is you're
Well, one's in playback, one's in record.
yeah, and you know how you get a feedback when you put a mic up to a speaker? Well, one track is the transducer, like a microphone that you're getting the sound from, and the other one is the speaker, and you're trying to do that to it, you know?
So like close proximity.
Yeah, the actual incident is happening with the gap between the 2 tracks, okay?
What is the gap, the distance between those 2 record heads? How close are they?
The tracks.
Yeah, the heads. Sure. The tracks 3 and 4. How close are they on that record head?
I don't know.
Like a
Close.
You know, it's not that much. Huh?
I remember they had it labeled out. It was like 0.02.
Yeah, whatever. All you need to know is that they're too doggone close to record onto the next track. That's all you gotta know. Okay. Hey, what's the space in between called?
Interface.
Huh?
Interface.
No. If you look at the heads, you see where the tracks go, and then there's another slot of metal in between. What's that? What's the term for that?
Small.
It's called a guard band.
Okay.
What's the order of heads we have on the tape machine? Race, record, and playback. Okay. What does the edit button do?
Spills tapes.
Okay. Well, how does it do that? Stops this.
Take up.
Stops the take up. Okay. Okay. Everything else functions. The capstan pulls the tape across the heads, and the supply reel supplies, but the take up reel doesn't take up, and it just spills off the machine. Yeah.
What's that again? What's that button there?
The edit button disengages the take up reel. The lifters will be back in, and you can listen to it. It's edit mode. The only thing different from edit mode and play mode are exactly the same, except for the take up reel. Edit mode and play mode. So you can hear the tape going across the heads, just like in playback, only you're not winding it up in the take up reel. Yeah.
Does the key back on that means the same thing, is that it?
The cue, that little lever you mean? Okay. Does anybody know what that does? Pulls the tape lifter away from the heads. Okay. Or more specifically, it's away from the heads during fast forward and rewind, but if you want to hear the songs go by, you can gently push it back in to the heads.
It defeats the lifters.
Yeah, it defeats the lifters. But one thing when you do that, turn the control room volume down when you're rewinding and you put the tape against the heads, because that music is going by so fast, it's such a high frequency, you can just pop your tweeters real easy. Yeah.
On the guard band, is that space in between on the heads or on the tape?
On the heads. And that's the space in between the recording gaps there. Okay. How fast? Yeah.
What would be an example of a ribbon speaker?
A what?
Ribbon speaker.
A ribbon speaker.
There's supposed to be a ribbon speaker.
I know about ribbon microphones.
There was a ribbon speaker.
Is there? Is that like?
They didn't give an example.
Just make Pioneer come out with a tweeter on there.
ESS.
Oh yeah. Okay.
Yeah.
Yeah. It's just a different way of transducing, isn't it?
It's foil. Yeah.
I always have ribbon pin these. You want to use them?
Yeah.
They've made full range ribbon transducers for low end even, but they're not. You can't put much power on.
Yeah.
That's not even playing speaks to be a ribbon speaker.
I've heard they are. I'm not quite sure what they do, but it's the same principle. It's not a cone type. It's a plate.
Are they electrostatic?
An example of the piezoelectric would be electrostatic tweeter.
Let me interject here. The scope of this conversation is way beyond that of the test. Okay? Some people are going, oh boy. You know, and the test is on really basic things you must know. Okay? Things that you probably are taking for granted. Okay? Does the EQ precede the fader or is it after? Precedes, doesn't it? What's the most common cause of distortion? Of the microphone preamp. Okay. Stuff like that, okay? Practical things. Things you need to know. Okay. This stuff is great to know too, but you know, we're trying to teach you a trade, not you know to be a scientist or anything. What other basic questions about recording or overdubs or operation of the machinery, operation of the console, or operation of the tape machine? How fast are we recording it at?
15 or 30.
15 IPS all the way through the studios. Now the half tracks, they have only 15 IPS, or can I select a speed? 7.5 also. Which will give me better quality? 15. Okay. But what's an argument for 7.5? Longer playing time. Economy. Okay. What about I've got a half track tape. Can I play it on a quarter track tape machine? I could, but it wouldn't track right, would it? Is it the same width tape?
Yes.
How wide is it?
1 inch.
Quarter inch. Quarter inch. How wide are the 8 tracks? Half inch and the MCI? 2 inch. Okay. Yeah.
So MCI, you play that 15 too?
Yeah. What's the speeds on that? 15 and 30.
Actually, it's
Huh?
variable.
Between 15 and 30, yeah.
Not completely. You can't turn the speed control and turn it from 15 to 30 with.
It's all
Right.
a certain range.
Plus or minus 10% is what it is. Is there a
The
question?
speed used to be 7.14.
Say that again?
Didn't the slowest speed for tape used to be 7.4 years back?
1 and 7/8 is about the slowest I've heard.
You mean the 7 speed?
What is 7?
I've always heard 7.5.
Yeah.
3 3/4, 7.
3 3/4 is 7.5. So it's 7.5 is half of 15, and 3 3/4 is half of 7.5, right?
And how fast do cassettes go? 1 and 7/8. And how wide is the tape? 1/8 of an inch.
What's the metric equivalent for 7.5 and 3 3/4? In millimeters.
Centimeters.
Look on the Pioneer quarter track, and you'll see 19 and something. Well, whatever half of 19 is, 8.5.
19 is the flattens. 15.
What
No,
does
7.5. 7.5 and 19.
what does SPL stand for? Sound pressure level.
How is it measured in dynes or decibels?
Sound pressure level.
Decibels.
Decibels.
Should be measured in time.
So we have to know any of the sport arms.
No, you won't have to know any formulas. There might be some simple arithmetic, something you could do in your head, or you'd have to scratch it out a little bit. No intense formulas. Huh? When I plug a microphone in the console, what's the first thing it sees?
Any of them.
Mike Lund.
Any of them.
Well, the studio master has got the mic in first.
Mike Lund.
Sphere console. And then preamp. Then
Line switch.
mic line. Then EQ. Fader. Bus a sign. And we bus a sign to the tape machine and come back to the monitor section. Okay, I've got a guitar plugged into 6 and I bus a sign into 2. Where's my EQ? This. What about the fader? What about what about headphones? 2. If it's in the studio master, you're on 6, bus a sign into 2. Where's the headphones?
Either.
Either one. In the studio master room, what's the first thing it sees? Mic line switch, and then pad, and then preamp, EQ, fader, bus sign. Okay. Now during mixdown, do I have to press 1 and 2 on the Sphere console? So it's constantly monitoring and monitor output. That's right. In the studio master, do we have to do that?
Yeah.
Okay. What can I use to patch in special effects during mixdown? Q system. Yeah.
You use the output of the headphone buses and send them to the inputs of your effects.
Where the output is.
The output of the Q system in Studio C is where? Where can you patch into the patch bay? And where do you get it in the on the Studio Master? On the back of the console, there's an output called foldback output, and you can route that to the input of your effects and use the green knobs to send things to the effects.
When you run the line back from the effects, you just plug it into one of the set unused channels.
One of the unused inputs.
What else? What other? You know, everybody knows what bias is. Somebody tell me what bias is.
So about the high frequency signal added to the recorded to be recorded signal.
That's right. Say that a little louder. There were some people talking.
It's a high frequency signal added to the signal being recorded.
That's right. And why do we have bias?
To compensate for the inherent nonlinearity of magnetic systems.
That's right. Okay, another whiz kid over here.
Let's hear that one again. Why do we have bias?
Compensate for the nonlinearity of the magnetic system.
In other words, so it sounds on playback like it was when you recorded it.
Still lacking.
Okay.
Do that with your eye.
What what would happen if we did overdubs in the playback head? A little delay action, wouldn't we? Yeah. Can I use that to my advantage? How? Huh? Forming my own delay? Hey, we got some ideas here. You mean I could do things like use the half track in Studio C, send the reverb to the half track and listen off the playback head. So when on my mix, every time the snare is hit, it would go pop, pop like that.
Be a double.
Oh, yeah. Yeah.
It would delay the first echo.
Yeah. It would make it sound a little bigger.
And then if you were doing that, how could you change the amount of delay of how quick this change the speed of the tape machine?
Yeah.
Does that change the frequency at all?
No, because it'd be recording it and playing it back at the same speed. So it'd just be a longer, since the tape's moving faster, it'd be a shorter delay time between the record and playback head. And if you put it on slow speed, it'd take longer for the sound to get from the record head to the playback head.
It wouldn't affect the frequency of the sound coming in.
No, those machines will record flat at 7.5 or 15. In fact, if you want even shorter times, you can use the cassette machine. But the tape moves slower, even though the heads are closer together, so it's not going to be directly proportional.
But you try more tape noise.
And more tape noise. What's it called when frequencies aren't as good coming in from the rear of a microphone? If you get off-axis coloration. What's it called when the bass increases when you move in toward the cardio?
What two miking techniques can we use to minimize phase cancellation?
3 to 1 is 3.
3 to 1, yeah.
What type of microphone must you use a balance cable for? Phantom power. Any microphone that you have phantom power, you must have a balanced cable. Because it actually uses the 3 wires to run that phantom power to the microphone. What type of microphone will take the highest sound pressure level? Dynamic. You guys ask the questions.
What's bandwidth?
Bandwidth is the space between the highest frequency that the sound is producing and the lowest frequency. If you're playing, the bandwidth of a transistor radio is smaller than that of a real hi-fi playback system, meaning that it won't go as high and it won't go as low. What's bandwidth of a equalizer means? The area that equalizer will affect.
What's the approximate bandwidth of our hearing? 20 to 25.
We have to know like specific microphone makes what they are.
You might be called upon to write down some manufacturers. You sure better know the three. You better know the three types of elements, the most popular elements, or
Types
yeah,
of
the three types, or the main two, which are condenser, dynamic. There's a ribbon too. What are these for CBs? Crystal. What about pickup patterns? What are the three most popular guys? Right, right. No, not. That's right. Omni, bi, and cardioid. Directional.
Does an electric microphone need a battery?
Yes.
It does.
Yeah.
Is the electric the one that has the plate on the condenser is polarized?
Yeah.
It's manufactured.
Why does an electret condenser need a battery if the plate's already polarized? You drive the preamp built into the microphone. And some models have an electronic impedance matching circuitry, which is the same as a transformer, except it's electronic. You change the high impedance capacitor to low impedance to go in your console.
Suppose we're miking a loud guitar in, and we're using a Neumann U87. And pull up your fader, hear distortion. Well, what's the first thing you want to do? Pad it. I'll pad it 15 dB. Takes a lot of the distortion away, but I still hear some distortion. So I pad it 30 and bring up the fader, and I don't get rid of the distortion, I just get more hiss. What could be wrong? I'm overloading what? The preamp in the microphone. Ah, so we have to pad it at the microphone. Right. There's a 10 dB pad on those mics. Now, it is true, though, that with a reasonably hot signal, the console will overload before the mic does. Because U87s can take a fair amount of SPL, and the console has a lower threshold. So the first thing you should go for is a console and leave the Neumann set. But if that doesn't do it, then you know you have to go to the microphone. But the important thing to remember is that there's a preamp even before you get to the console, okay? And that's in the microphone itself, so you have to always remember that.
What does the loudness switch on your stereo do? Why do we need to? When would we use the loudness control?
While we're playing quiet.
At low volume, because what happens to our ears at low frequencies at low volumes?
Hear the mid range, but everything else.
We're less sensible to bass and high end.
Insensible.
At low levels.
What's this?
Our ears do not hear low frequencies at low volumes as we do at higher volumes. In other words, the lower we turn down a stereo, the less we hear bass frequencies and high frequencies too, but mostly bass. There's a nice graph of that in the Warren book. Yeah, what's that called? Fletcher-Munson curve. Boy, that's a handy thing to know.
Hey, dude, he's talking to your neighbors.
Yeah. Right. We're not going to nitpick at little features of the compressor and the outboard gear. What we do want you to know is the general operation, or what it does, okay? That's all.
Is the gain reduction or peak reduction knob on all the compressors we have input or output gain? Input. The peak reduction or gain reduction knob is input gains, and the gain knob is output. What's the difference between a limiter and a compressor?
Compressor to implement the limiter.
Not necessarily. There's a real easy definition. Ratio. Anything more than 10 to 1 is a limiter. They just grabbed that 10 to 1 as a basis. What's the ratio mean on a compression? It's the ratio between the input and the output levels. If you increase the compression ratio, do you get more or less output? Less output. If you reduce the compression ratio, more output. If you have a compression ratio of 8 to 1 and you put 1 volt in, you put 8 volts in, how many volts do you get out? If you have a compression ratio of 2 to 1 and you put in 8 volts, how many volts do you get out? 4.
Is that our simple math test?
Something like that, yeah.
The threshold where the compression starts?
Exactly.
What is the rotation point of compressor? What does that mean?
That's
What?
okay, the old graph here. Frequency versus amplitude and all that good stuff. Okay? As we increase the node in volume, say we have a sine wave or whatever, we can turn it up in volume, okay? What's going to happen is with the threshold knob on the compressor, I'm bringing down the threshold maybe to about here, okay? So this will be our threshold right there. Now, whenever this volume gets up to here, okay, if it dances around here, then am I going to compress or limit? No, I'm not. Not until I exceed the threshold, okay? To set the, okay, so if I go up here and I have the compressor set at 2 to 1, okay, it's going to compress it that much, okay? Cut it in half, all right? 10 to 1 would be right here, okay? This is your rotation point. What was the compression ratio? But you were speaking of the rotation point. That's I forgot. That's right there, okay? So what you're doing is as you set the ratio, you're going 2 to 1, bing. 8 to 1, bing. 10 to 1, bing. 20 to 1 is like that, and that's like squashing the music.
So it's just where the compression ratio crosses the threshold.
Right, right. Yeah.
Say threshold, you're not talking about, it's like
You're lowering the ceiling, okay?
Yeah.
You're lowering the ceiling, and every time I pop my head above this line, the compressor's going to yap me on the head and push me back up.
So wait, play.
That's distortion or saturation, right? That's not.
No, that's just the point at where the thing starts to operate.
Yeah.
The thresholds are fixed, but then you have a thing called peak reduction, and that's really the input gain. That turns up the signal you're sending to it until it reaches the threshold point.
Does the compressor always bring up the lower levels too?
It will bring up the low levels as it'll
It
compress.
does work from both ends.
Yeah.
The reason it brings up the low levels is because if you restrict the dynamic range, then you can turn the gain up. That's how your lower ones come up. If you just set the threshold and don't adjust the gain of the thing, then you're just flapping the top off. But if you set the threshold and then boost the gain, all your lower levels are up, but you don't have to worry about the hotter ones sliding through.
What effect does an expander have on the lower level?
An expander will actually turn down the lower ones as it turns up the louder ones.
Like he said. An expander is just the opposite of a compressor. Okay, with a compressor, you're squashing the dynamic range. Okay, with an expander, you're making the louder notes louder and the softer notes softer. Okay, so if the music stops for a second before it comes in again, the bottom is just going to drop out and you'll hear nothing. And then as soon as the music comes in again, it'll come up. Okay. Maybe not.
On the sphere console, why would that matter when you have the same
Why doesn't it matter if you have the sync button in or out on the Sphere console? First of all, what is the sync button on the Sphere console? What is it on the Studio Master? It's a line in, line out switch.
Yeah.
Okay. Now, the reason we don't need it, number one, is because of a feature on the tape machine, which I can listen line in and line out with. What can I do with there? I can punch it to tape or source. Okay. If those sync buttons are down, I'm listening after the multi-track. Well, obviously, sometimes I'm going to need to listen before the multi-track. Or rather than fool with the sync switches, what I'll do is I'll do it on the tape machine. That way, you're not looking at two things all the time. You're just doing all that business with the tape machine only, and you don't have to worry about the sync buttons. Now, there's a deeper reason why the sync buttons they're not happening like they should, and that is that Sphere Console thought that they'd be a step ahead of the ball game by putting some of the functions on the tape machine in the console. Well, as you know, the autolocator has all the functions right there, and the sync button is not being used to its fullest capacity. Okay. In other words, there are three things I can listen to on a professional tape machine. What's one of them? The source, playback head, record head. Well, Sphere Console thought, well, let's put those buttons on the console. Well, we have them on the MCI, and they're still manufacturing tape decks that way, except for some consoles like Harrison and stuff, where the tape machine company and the console company get together and they sit down and say, okay, let's do it right. Okay. But in the situation here, Sphere was thinking, okay, well, it just never evolved, and we can still do all the functions on the tape machine, and the sync button is only being half used. It will do some functions for us, but they're pretty minor. Okay. That's the reason you don't really have to deal with the sync buttons during normal operation. And in fact, unless I'm doing something real fancy, whether it's basic tracks, overdubs, or mix down, I will never touch those things at all. Sync button and the bus button on the side.
It's a Q button on the auto locator.
Pardon me?
What's the Q button for on auto locator?
On the auto locator, it has tape, input, and auto. Tape is what? Playback head. Input is source. What's auto then?
Record.
Record head, monitoring off the record head.
Isn't there a Q button on it?
It says Q, and MCI, when they're speaking of the word Q, they mean listening off the record head. It's funny. Manufacturers will use different names for different things, okay? Like they have echo for the reverb sends. Well, it doesn't matter what it is. You can hook up anything up to it, but they call it that. And MCI calls being in sync, it's in the Q mode. Okay. Well, what did we say the little Q lever was on the Atari machines? It defeats the tape lifter. Okay, so that's a Q on an Atari machine. Okay. So there's a little gray area on some of the terminology. That's just something you have to know about, and when you're dealing with the machinery, you'll find out things like that, and that's just one of them. Yeah.
What does keep stand for?
I don't know.
It's a trade name.
It's just, yeah.
It's,
It stands for something.
Cable program expander.
Say that again.
Cable program expander.
Yeah. Okay.
That sounds good.
Keyable program expander. I didn't know that. Did you have a question, Austin? That was your question too? Oh, okay.
Sync button and on the sphere console.
The only thing the sync button does, okay, you don't have to, if this doesn't sink in, it's okay.
Sink in.
Sink it? The only thing the sync button does during mixdown is with the buttons in, I can read the meters 1 through 16 showing me what's on tape, and also it sends my input to the monitor section. So I can use the cue system for special effects during mixdown. Now, that's one of the things. See, I said leave the cue buttons in, sync buttons in all the time. Here it is. With the sync buttons out, I can't use the foldback system for effect send because we won't send it to the monitors. Okay? That's just the way it is, all right? I mean, that's the way it was designed. Now, I can use that to my advantage once in a while when I'm bus assigning things. Also, I need to have the sync button in when I'm bus assigning during mixdown. And there's another situation where what you might want to do is, like we said before, use an piece of outboard gear like a half-track tape machine for a delay on our reverb. What we do is we bus assign the channels that we want to be zapped by the half-track, and then we take program bus out, patch bay. Well, if I didn't have the sync buttons in, it wouldn't send it there. So don't worry about that. These are little innuendos that you learn about when you get your individual console. You know, this is just a little, a thing that's with Sphere, and another console will be different. Okay, so like I said, leave the sync buttons in all the time, whether you're doing basic tracks, overdubs, mixdown, and you'll be a happy group of guys.
What's the one feature that the Studio Master EQ doesn't have that the Orban Parasound does?
Variable bandwidth.
Variable bandwidth.
What is adjustable on a parametric? What can we adjust? Bandwidth, frequency, amplitude. What's amplitude? Volume. Okay. Can I do that on a graphic equalizer? I can adjust what? Frequency is selected for me, isn't it?
Frequency's already there.
Amplitude?
It's already there.
That's right. What about on the TAC machine and the 3-band EQ on the Sphere console? Say the bass and treble, what can I adjust there?
Wide and narrow.
It's just the mid-range.
Just on the, not speaking about the mid-range, what can I adjust on the 3-band EQs on the Sphere at 10K and at 100K? I gave half the answer away there.
Just boost.
I can just boost or cut. That's all. Okay, now the mid frequencies, I can select the frequencies and I can boost or cut, and there's a minor added feature. What's that?
The wide and narrow.
Wide and narrow bandwidth, and there's little green numbers and white numbers, and which is which? That's right. White is wide, green is narrow.
Okay.
These are the kind of things, things that you should know, and maybe some of you are taking for granted because you're searching for, learning the new stuff,
What's the difference between an active and a passive crossover?
One's before the amplifier, one's one before it.
One's before the amp and one's after the amp. Which one's before the amp? Active. Which one's after the amp? What kind are we using here in all the studios? Active or passive? Crossover. Passive.
Why?
Why? Because all the speaker cabinets.
Yeah.
Before it comes on that speaker console, get the pads right up front. Set gray button for on the right side.
What is that?
Mic line
It's a mic line switch. On the Sphere console, the gray button is the mic line switch, yes. And when I'm in line, the switch is down.
So when you're mixing down, all
Comes up.
Yes. When you're mixing down, all the buttons should be down. When you're recording, all the buttons should be up. What's the one other feature on the Sphere console we need to be concerned about during mixdown? The mixdown button, which is over on the right-hand side on the monitor section.
What does that thing do?
It defeats the black monitor knobs. You're trying to get me, aren't you? It defeats the black monitor knobs. So your new volume knobs are the faders instead. Okay.
But you still have use of the balance.
Yes, you still have use of the pan knob, still have use of the reverb, still can use the cue system. How about the cut button? Can I still use the cut button during mixdown? Yep. During mixdown, what you hear is what you get. If you're doing your mixdown and you're rolling tape and you solo something out, guess what? That's what you hear on tape. Okay?
Is there a way of doing that and not getting it on tape?
No.
Spirit? No.
By the time you're rolling tape, you should be listening to the whole situation. So remember that. That's a good rule to follow. Yeah.
Just for a question, if you like have a bunch of music real loud, it's real loud playing, and somewhere in the tracks you've got a piano just go, and you press the solo button, how much of a will it just go and stop?
Yeah.
And go right into it? I mean, like a real crisp tone on the piano, like that, depending on how you would do it, cue it or something like that. But is there any after effects that comes when you press that solo button? If you would tape it like that, is there any noise and switch?
In other words, you wanted to do that
On
purposely, to do some kind of bizarre arrangement.
Yeah.
No, it would sound all right. There would be no clicking or switch sound. It would just go back and forth.
Depends on which channel you're on. No, technically, they should work silently. I mean, go ahead and try it.
What meters do I have to be concerned about in the Sphere console during mixdown? Stereo bus meters. Okay. No questions or why?
How does a phase shifter work?
How does a phase shifter work? Phasing and flanging. It's the same ends with different means. Okay? What we're hearing is that swishing sound. Okay? Hook it up to a phaser or flanger and you hear a swishing sound. A flanger, okay, you're getting the end result in the same way. Almost the end result, but they're going towards the same thing. A flanger does it by time delay. A phase shifter does it with fancy equalizers. That is the difference in one sentence. Okay? To be more specific, what a flanger does is it takes your direct signal. Okay? It sends it through another channel and branches it off. And it does what it does to one channel is delay it ever so slightly. Okay? Our ears are lazy in that we can't hear small increments in delay. Okay? Very small. I'm talking 5 milliseconds. Okay? What happens is we can hear da da, okay, and da da, da da, da da, da da, all the way up till almost the same. And what happens is this phenomenon, this out of phaseness, okay, in which it gets so close we don't hear it as time delay, but rather we hear it as peaks and dips and frequencies, and it will give us that phasing and swishing sound. Now, the key word there is peaks and dips and frequencies, because what a phase shifter does is it makes itself a parametric equalizer. It dips frequencies out, and it has a little critter in there that rolls the frequency knob, and it rolls back and forth these dips back and forth across the other spectrum. Low frequencies up to high frequencies up to low frequencies. And that gives you that sound, that swishing sound. Okay.
Is that sweep variable?
Yeah, lots of cases it is. So you can make it go faster or slower. Now, a phase shifter, the difference between a good one and a cheap one is that for a good one, you need a lot of these little dips, which means you have to have a lot of little equalizers and to tack on a lot of guys to run it up and down the frequency band. Whereas a flanger, all it does is just go damp like that, and the whole audio spectrum is out of phase, going up and down. Okay, so you have to get a very expensive phase shifter to make it sound as good as a flanger. But even an electronic flanger is, oh, I shouldn't say that because they're making them so good nowadays. You know how this flanging business got started? Some guy running a tape machine was making dubs, and he put his finger, leaned against the flange of the reel of tape, and gave it that slight delay, and it was just poof, this out of phase, this swishing sound. Okay? And they've called it flanging ever since, and that's how they've been doing it up until 1970s when they started getting into solid state circuitry, the advanced solid state circuitry, where they could do flanging and that sort of thing.
Doesn't flanging involve a little bit of pitch variation also? Not just the...
Because on more of the flanger, you can make it sound like a motor swing or something.
Yeah, the electroharmonics theirs can make it very pitched somehow too. I'm not exactly sure on the operation of that. I'm not real clear on how it does that, but might have something to do with the out of phaseness of the dips and peaks. Sounds good. I'm not real sure on that question. Yeah.
What is the feedback circuit on harmonizer? I think it has a feedback circuit.
What the harmonizer does is it has a knob with feedback. What it does is, okay, you feed the information in, gets zapped by the harmonizer, and out it goes back to the console. Well, what you can do is feed that output back to the input. Okay, so in the case of a snare drum going in, it'll go back out. It'll go da, feedback in and go da. So you go da da. Okay, turn it up a little more, and you maybe go da da. Turn it up a little more, it's da 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 da. You know, so it's feeding back the output back into the input.
Feedback just the drive signal or just feedback to
It's a combined. Yeah. What else? Meet the press.
What's the one word that describes the attack, the sustain, and decay of a musical waveform? Envelope. Envelope for you Midwesterners.
What is transience? It's a sharp peak. It's a very fast attack and a very rapid decay. Well, give me an example of one.
snare drum.
Snare drum. Okay.
Doesn't necessarily have to have a rap.
Not necessarily, but it may have a high peak and then come down and then do
That's
that.
the semicolon thing. Or
Yeah.
anything.
Mm-hmm. Yeah.
What device do we use to control the envelope?
The attack and release.
Compressor or limiter?
Which one?
Either one. I mean both. We're gonna give you all answers if we keep.
Yeah. Right, man. I tell you, you guys are pretty good, huh? I mean, it's awful quiet out there.
What's not there?
Like I said, it's just things that you should know. Okay, things that you've heard us say more than once. All right, or you've seen more than once. Now the test is basically based on the lectures, and the book is supplementary. All right. So if you take good notes, you should have no problem with the test.
Everybody think of what the foggiest thing in their mind about any of this is and throw it out here.
Job.
John.
What you
That's not on the test. Well, if there's no further questions, I mean, I think I've covered about everything that I think you should know. Anyway, of course, I left a little bit for you to study, but they're the same thing, around the same thing. It's all practical, okay?
Are we going to be tested on any of the music publishing stuff?
No music publishing, no business, none of that paperwork stuff.
Toggle any lines in, lines out, anything like that.
You don't have to know how many.
Yeah, that's what I mean, yes.
Right. Yeah.
What was the one advantage again of having the erase and the record head on a closed loop so close together? On a closed loop.
Erase had a record head on a closed loop.
Yeah, on a closed loop tape recorder, they said there was an advantage to having the erase and the record head closer to each other.
Switch it in.
What is it? Does anybody know?
Switch in for space.
Okay. Yeah. Yeah. Look at all these questions today. Yeah. Know the basic ones and know what different types of microphones there are, different pickup patterns. Okay.
What's a DBV?
dBV.
Yeah.
It's a measure of decibels with respect to voltage. Yes.
dBm.
CBN. There's that
I
too.
thought it was with respect to voltage, but there's a passage here, on page 39 in your manuals.
Yeah.
Which is talking about an acoustic pressure in front of a microphone that creates an
Yeah.
output level.
Right.
So they're measuring the acoustic in electrical terms.
Yeah.
Right. Well, they're saying that more sound pressure is going to raise the voltage on the output.
Yeah.
You got to have a formula that includes SPL and volts. You got to have some term that expresses both of them. Thus, dBV. Just like foot pounds or something. That's decibels volts.
And the M in dBm.
Increase is a dBV.
What?
It increase in the dB, SPL, dB. What'd you say? Increase in one will increase the other.
Yeah.
Yeah, but a dBm is what the M refers to millivolts.
Yeah.
Millivolts.
Reference level, millivolts. Yeah.
Well, if there's no other questions, we'll see you in the studios. Yeah.
Hey.